I will be finding the radius and interval of convergence of the series f of x equals the series from n equals 3 to infinity minus 2 to the n times x plus 3 to the n all over n times the square root of the natural log of n. We will start, like all power series, by taking the ratio test, which states that the limit as n approaches infinity of the absolute value of a of n plus 1 over a of n is less than or equal to 1 if the series converges. So we will do this by taking the limit as n approaches infinity of the absolute value, and because we're taking the absolute value, we can just get rid of this negative sign in front of the 2. So for 2 to the n plus 1 can also be written as 2 times 2 to the n, and the same thing with this x plus 3 to the n times x plus 3 times x plus 3 to the n all over n plus 1 times the square root of the natural log of n plus 1, then multiplied by the reciprocal of a of n. So the reciprocal of a of n is this flipped around. So it's n times the square root of the natural log of n over 2 to the n times x plus 3 to the n less than 1. So here we can cancel out this 2 to the n and the x plus 3 to the n, and then we can pull this 2 and this x plus 3 out of the limit. So we have the absolute value of 2 times x plus 3 times the limit as n approaches infinity of the absolute value of n times the square root of the natural log of n over n plus 1 times the square root of the natural log of n plus 1, which this limit approaches to 1. And this whole expression is less than 1 if the series converges. So that leaves us with the absolute value of 2 times the absolute value of x plus 3 is less than 1. Absolute value of 2 is just 2, so the absolute value of x plus 3 is less than 1/2. So this means that the radius is 1/2. Okay, so now that we found the radius, we can find the interval. So we get rid of these absolute value signs by saying that minus 1/2 is less than, we don't know if it's less than or equal to or not. X plus 3 less than, we don't know if it's equal to 1/2. 3. We isolate x, leaving minus 7/2 is less than x less than minus 5/2. We can see these are 1 apart, which is twice our radius. So now we need to test these endpoints to see if they converge. So we'll start with for x is equal to minus 7/2. F of minus 7/2 is equal to the series from n equals 3 to infinity of minus 2 to the n times minus 7/2 plus 3 to the n all over n times the natural log of n square root. Now this here is equal to minus 1/2. So with minus 2 to the n times minus 1/2, that is equal to just 1. So f of minus 7/2 is equal to the sum of, from n equals 3 to infinity of 1 over n times the square root of the natural log of n. Now here we can't use the p-test because it's not just a polynomial on the bottom, but here we can integrate this. So we're going to let g of x, we can't use f because that's the series, equals 1 over x times the square root of the natural log of x. No, let me fix that for you. With this, and then g of x is positive, continuous, and decreasing from 3 to infinity, which is our interval here. So now, to see if this converges, we integrate g of x. So it's the integral of from these bounds, so that's from 3 to infinity, of 1 over x times 1 over square root of ln of x times dx. And then here, this is a u substitution, so we can right over here say that u is equal to ln of x. So du is equal to dx over x. Dx over x is here, that's our du. Here's our u substitution. So we're left with an integral. We have to leave out these bounds because I don't want to put in what u is equal to, of 1 over square root of u du. And then when we integrate that, we get 2 times the square root of u, which is equal to 2 times the square root of the natural log of x. Bring back the bounds from 3 to infinity. And then we can see if we, when we plug in these bounds, we get 2 times the square root of infinity, which is infinity, minus 2 times the square root of the natural log of 3, which this goes to infinity, so infinity minus a finite number is infinity. So therefore, diverges at x equals minus 7 halves. Let me grab another piece of paper. Okay. So now we need to check the other point, which was let x equal to negative 5 halves. So for letting x equals to negative 5 halves, f of negative 5 halves is equal to the series from n equals 3 to infinity of minus 2 to the n times minus 5 halves plus 3 is equal to 1 half times 1 half to the n over n times the square root of the natural log of n, which is equal to the series from n equals 3 to infinity. Minus 2 to the n times 1 half to the n is equal to minus 1 to the n over n times square root natural log of n. So here, because we have an alternating series, we can use the alternating series test. So AST. So we need to find the positive part of the series. We'll call that A of n. A of n is equal to 1 over n times the square root of the natural log of n. And we can see that A of n is always positive and always decreasing. So A of n is greater than 0 and is decreasing on entire interval, let's call it. Okay, so now with the alternating series test, it is decreasing. So now we need to take the limit AST as n approaches infinity of A of n, which is equal to the limit as A approaches infinity of 1 over n times the square root of the natural log of n, which is equal to 1 over infinity times square root of infinity, which is 0. Limit n approaches infinity. Keep notation appropriate. Okay, so because it equals 0, it is convergent at x. Therefore, series converges at x equals minus 5 halves by alternating series test. So overall, our final radius r is equal to 1 half And our interval of convergence is from minus 7 over 2 open, comma, minus 5 over 2 closed. So what this means, sorry about that wait, what this means is that for any x value, you plug into this series and into this function, this will come to a finite answer. Otherwise, if you get too far away, it'll diverge and go to infinity. Thanks.